Hi, welcome to this workshop on Introduction to Artificial Intelligence or Machine Learning, or what we call the AI Primer Workshop. So by the end of this workshop, you will be expected to know the following. So understand what is artificial intelligence, understand what is machine learning, and after that we'll go a little bit deeper into supervised learning. Then within the different topics in supervised learning, we'll go into linear regression and then followed by neural networks. So by the end of this very short course, you will be able to understand in particular what is AI, what is the difference between AI and machine learning, what are the kinds of machine learning techniques that are there, and in terms of supervised learning, in particular what is linear regression, what is neural networks, and with that understanding you'll be able to know then what is in fact what is common term that we see nowadays, deep learning. Okay, without further delay, we'll dive straight right in. So welcome to the first workbook on Introduction to AI. We'll be covering two topics in this workbook. So firstly, what is the difference between general AI as compared to narrow AI, and also what are the different categories of, in our case, will be that of the narrow AI. So the objectives will be to distinguish different types of AI. So the first topic, which is the general versus the narrow AI. So in terms of the recent advances that we've seen of late, be it playing of chess, playing of Dota, or even like autonomous driving, all these belong to the realm of narrow AI, and the reason is because they are doing a specific task that we are asking them to do. So this is in contrast with the general AI that we hear about, which is it seems that for those the machines have a kind of sort of a cognitive common sense that they are able to work and act upon. So you see that in popular movies or culture like in Terminator, or even in the Avengers Iron Man, we have Jarvis or Friday. All these they belong to the realm of the general AI. Useful advances that we have seen, they all belong to the realm of narrow AI, and because of that, for the rest of the workshop, we'll be focusing only on narrow AI. So we'll dive into the different categories for narrow AI. So these four categories they came from Russell and Norvig. They wrote the very classic textbook, which is AI: A Modern Approach. The first category is that of thinking humanly, which is to design a system that thinks like a human being. Then you have that of thinking rationally, where you have all your first order logic. You have acting humanly, you have things like a Turing test, and also acting rationally, which is a rational agent where it tries to achieve the best outcome or the best expected outcome. So we narrow into the first category, which is that of thinking humanly, designing a system that thinks like a human being. So this was the study where many advances like perceptron or the neural network was being founded. They literally wanted to understand and to create a computer system that thinks the way a human being thinks biologically, and hence that in fact inspired the perceptron and the neural network. It's still very important in today's so-called in today's landscape, whereby the field of systems biology, whereby they really try to kind of simulate how a human being thinks. The second class is that of thinking rationally, where they try to break down everything into certain rules or logical constructs. Of course, it is really challenging to do that. However, if you are able to carry that out for certain tasks, then you will realize that these equations actually can make your solution very deterministic rather than stochastic. So the next class of algorithms is that of the acting humanly, and I'm sure you heard of something called the Turing test. So the Turing test is where the human person is sitting in front of a veil, and at the other end of the veil is either a machine or another human. So the Turing test is if the human that is before the veil is unable to determine if on the other side is it another machine or another human being. So you can imagine that if for certain tasks, this test may not be as critical anymore. So for example, for the algorithms that defeated the chess players or even the Go players, we know that these are in fact machines, and that doesn't so-called that doesn't discount the fact that they are indeed very sophisticated AI machines. So for those tasks in particular, it does seem that the Turing test is not as relevant anymore. So if I may use the example like a jet engine. So we are currently interested in building the jet engine that can fly us from the in the shortest amount of time from point A to point B. We are not designing a jet engine that flies like a bird until it can deceive another bird into thinking that the jet engine is a bird. So that is one of the analogies that have been put forth on the relevance of the Turing test for today. So the final category of narrow AI is that of acting rationally. So this is the class of algorithms that we'll be focusing primarily on for this workshop. It deals with both things like expert systems or even machine learning, where we don't really explicitly tell the machine how to behave, but instead it relies on a set of data or patterns or inferences instead.